Welcome back. We're tooling along here in Module 6 where we're talking about vector network model. Last time I talked about some of the applications for the network model, and a lot of those are applications that have some commercial value, and you can do things like find an optimum route, a traveling salesperson, closest facility, location allocation modeling, a lot of things you can do with a network when it turns out that straight shot is not the way to go. So this time I want to talk about a couple of data sets that you can get for free from the government that you can use to do your own network analyses. Tiger. You saw some stuff when Courtney made the video back in maybe Module 3 or Module 4 that was. Courtney made a video of where to get data on the internet. She talked about the census. Census provides a lot of population and demographic data, but it also turns out provides a lot of geographic data. And that geographic data was required by the census in order to aggregate head counts of humans into what are called enumeration units. So about 25 years ago, they decided they needed to make some geographic enumeration units that would allow them to efficiently aggregate counts of people. Okay? And one of the things about this is that the geographic entity hierarchies, the enumeration units for the population counts, are kind of like Russian nested dolls. And so each smaller unit fits inside of a larger unit. So when you add up all of the little units, you can get to the totals that are in bigger units. So the higher up you go in the hierarchy, everything adds up, everything works well. And you can imagine in vector analysis that this is going to be kind of important, because if you're going to overlay things, it's going to be much better when you overlay things that are nested so that you don't get pieces of separate enumeration units. And remember back in, I think it was Module 4, I talked about the modifiable areal unit problem, where the numbers that you get in your map depends upon the size and the shape of the enumeration units that you have. So if you're talking about the size of the units in the census, the largest size will probably be the country, the numbers for the country, and the smallest size is going to be what's called a block. What you get is, the smaller your enumeration unit is, generally the more variation you'll get in your data. So as you go to larger and larger enumeration units, you're going to get less variation. Also remember that depending upon the shape of your enumeration units, you can get different numbers. So you can kind of mess with the data to have it give you the answer you want. And the example of that is gerrymandering. They use it in politics for voting districts. The census wanted to get away from that and make it a political neutral entity hierarchy, so they came up with this hierarchy about 25 years ago. This is the way it works. At the lowest level are blocks, and larger levels go to groups of blocks. Groups of blocks are aggregated into tracts. Tracts are aggregated into counties, counties to states, states to division, regions, and nation. So when you go up this hierarchy, if you go straight up this line, each one of the lower levels in the hierarchy is going to nest in the higher levels. So that's going to be really good for overlays, if you want to do overlays. If you go off this main axis and use overlays that use some of these other census geometries, you're going to end up having issues when you do overlays. So if you try to overlay places with blocks, you might get blocks from two different block groups that are in a certain place, and your numbers are going to come out funny because the aggregation again is by this unit. Okay, so Courtney showed you how to get census data from kind of a more graphical interface. Another way to get census data is from the FTP site that the census has, and this is the FTP site for the Tiger data. And I wanted to say that Tiger is topologically integrated geographic entity reference, is maybe what that stands for. The key here is topologically integrated. So we're going to be able to get network data for lines of streets that we'll be able to use to do network analysis. So remember, in networks, lines are called edges, so you can go out to the FTP site, where the directory edges is, and you can drill down to the area that you're interested in, and you can download all the edges associated with the area that you're interested in. When you drill down a little further, you'll see that these files come out as zip files. This stands for Tiger Line. This is the year of them because they do change shape over time. This is a code that tells you what state it is. They're alphanumerically coded, so the lowest alphabet numbers, Alaska and Arizona and Alabama, are going to have the lowest first two digits, and then the last two digits are the county numbers. So if you know your counties, you can go to Idaho and Latah County and get the edges for Latah County. So I did that, and I clipped it to places, and this is the road network in Moscow, Idaho. And remember, when I clipped it to places, I'm going to have maybe an issue with any kind of population information because these may not necessarily line up with blocks. But since I'm just looking at street network, everything should be fine. Okay, so when I look at Moscow, Idaho street network, and I highlight this line segment in the network, it actually happens to be the block that I live on, and I look in my attribute table, I see that this segment is a polyline. It comes from Idaho. Comes from Latah County. There are some ID numbers here. This is a number that tells you what type of street or road it is. Different numbers will be different size of roads or types of roads. Here's the full name, South Roosevelt Street. And if you continue on in the attribute table, you see that there are from addresses and to addresses on the left side, and from addresses and to addresses on the right side. So using this information in the table, if I get what's called an address locator, I'm going to be able to look up an address, and it's going to be able to find the line segment that that address belongs to, and it's going to be able to interpolate. Like in my example, I live at 323 South Roosevelt, so I'm going to be able to interpolate between 301 and 499, and I'm going to be able to determine where a point might fall on that line that would associate with my house. Okay, you can get the basic edges. You can download those edges from the FTP site. You can also download a whole bunch of other tables, and these tables look really confusing, but remember back in module 5, I think it was, where I told you how you can join or relate non-spatial data to spatial data? Well, this is the spatial data here, and all these other tables are non-spatial data, but you can join them using a primary key. In this case, it's TLID. So if I store TLID in another table that's not spatial, I can link these two or join them together, and I can access all of these other attributes. And you can see that there are a lot more attributes in the address here, like prefixes and suffixes and directions and things like that. So I can get a lot finer tuned geocoding or network analysis, finding points on lines, if I can link my spatial data to data that has more information. And the census Tiger data will provide that for you. Okay, so here I have prefix, direction, prefix type, prefix qualifier. So you can think about things like, is street ST, is it STREET, is it S? What if you have a North Roosevelt and a South Roosevelt? You've got to have a direction prefix. What if you have Roosevelt Northwest, Roosevelt Northeast? You might have to have a suffix direction. So you can see where to look up an address in a table, you need to have a lot of attribute information. Okay, so what's this thing called geocoding? That's finding a location on this network from an address. And so what it's going to do is it's going to do what's called linear referencing. It's going to locate the line segment or the edge in your network, and it's going to match the number you're looking for with an interpolation between the endpoints of the line that falls on. So it's a linear reference. How does it work? You've got a bunch of addresses. They can be tables, they can be single address, anything like that. That's called the input data set. Doesn't have spatial information, just addresses. Then you've got this reference data set, and this is the network that has the street locations. Tiger, census gives you can get the street networks for the entire country using that, so you can find addresses using these Tiger edges. You have to create something called an address locator, and what the address locator is going to do is it's going to take your address, and using an algorithm, it's going to look up in the edges where that address should be. And so there are a whole bunch of different kinds of locators you can make depending upon what the attributes in your attribute table are. But once you've created an address locator and you have a reference data set, you can give it an address, it'll look in the data set, and it'll provide a point, a vector point representing that address. There's a workflow associated with geocoding. The key to the workflow is building or obtaining the reference data. When you watch the video about the UPS delivery people, they have a really complex network, and you can see a lot of people working on that network all the time. You ever seen a Google car driving around? That's going to help make Google's network so you can have Street View and things like that. It's a really involved process building this reference data. Once you do that, you can walk through the workflow to go from your reference data and an address to locating those points on your map. Okay, here's an example that I did in class. The input data set were all the schools in Moscow, Idaho, just addresses separated by commas. And you can see that this is the main attribute. It's kind of the full name of the address. And so my locator is going to need to look at that name and find it on the network and try to put a point there. Here's my reference data set. You can see that South Blaine Street is one of the schools. I have something called S Blaine Street. So my locator is going to need to know the difference between the word south and the letter S. Okay, that locator is going to be told, look in this field for this address and try to tell me where it is. When you do that, it finds the proper address and it makes a point there. I symbolize that as a school. Everybody remembers back in Module 3, cartography, and using the language that represents symbology properly. And you can even tell the locator to actually move the point off of the network so that the school isn't really in the middle of the road, but it's a certain distance offset. There's a lot of things you can do with these locators, because when it doesn't find an exact match, it can tell you how confident it is in its match. You can do rematching, you can do a whole bunch of things with these geocoding algorithms. Okay, so that was a transportation network. There's another type of network, which is the directed network, and one of the main data sets you can use that represents a directed network is the National Hydrography data set, and that's the data set of surface water features. And so you can get a surface water network for the entire country by going out to the USGS site and downloading the hydrography data set, NHD it's called. So that contains a flow network, in addition to a whole bunch of other things for water bodies and other geometries, kind of like the census, but it's for surface water features. Okay, so how do you get this data? Well, I'll tell you how it works. It's also the geography associated with the hydrologic data set is a high level at regions. And so the watershed at its highest level here in region 17 looks like the Columbia River watershed. Okay. The regions will nest just like census enumeration units nest, smaller and smaller units. And so this is what's called a hydrologic unit, HU, and it has a code associated with it. HU 17 is this hydrologic unit. So that's called the 2-digit hydrologic unit code. Sometimes you'll hear the word HUC, hydrologic unit code. So 2-digit code are these largest regions. You can subdivide the largest region into a smaller region. That becomes a 4-digit code. So all the 4-digit codes nest in the 2-digit code. You can go down even further. This is 2, 4, 6, 8-digit codes. So each one of these 8-digit codes nests in the 6-digit code, which net in the 4 and in the 2. Getting the idea here? And you can go all the way to 12-digit HUCs, which are the smallest representations, the smallest geographies of this hydrologic data set. You can get the stream network in any one of these regions. Okay, you can go out to the FTP site to get this. It's similar to the census site. You need to find the code that you're looking for. The region would be the first 2 digits, and you can go down further to 4 digits, download these. They're going to come up as file geodatabases when you download them. Another way you can get the data, and this is what happens when you download them, you get a file geodatabase, and notice how a network is going to have to be stored in a data set. And so here's the network, and the network contains junctions, and edges. So it has the flow lines, those are the edges, and the junctions are where different edges or different tributaries meet, or other junctions that may be in place, like dams and streams and valves and things like that. Okay. If you don't want to go to the FTP site, you can go out to the National Map Viewer, which has all kinds of data at it. You can just Google National Map Viewer and go to that link, and it'll open up a viewer that looks like this. And what you can do is you can select geographies that you want to get information for. And so in this case I'm saying I want, I think this is a 8-digit hydrologic unit geography, and when you click on that box and then go click on your map, it'll highlight that certain hydrologic unit. And then when you click over here on download, it'll tell you what all type of data you can download associated with that geography. And so I'm interested in the hydrography NHD dataset, so I check on that. It gives me another box that tells me what all I can get from that hydrography dataset in this geometry. And in this case I'm going to get a file geodatabase. It's going to extract the 8-digit geography from the 4-digit geography, which is kind of the default geography. So when you click on that and then you click on next, it's going to have you give it your email address. It'll put together the data set for you. It'll send you an email with a link, and you click on the link and you can download the geodatabase. So that's how you get this network. Okay, that was 2 quick examples of network data sets you can get free from the government to do transportation networks and surface water networks. That's the last kind of main video in this module. So next time what I'll probably do is wrap up the first half of the course, because we're now at the point where you're going to be getting ready to take a midterm. So I'll quickly summarize in the next video where we've been so far and maybe give you a little preview about where we'll go after midterms. So that'll be next time. Thanks for watching.